This is a practice Seaborn exercise. I am doing it for my own purpose to review it later. Let's start by importing the libraries. First up, it's import numpy as np, import pandas as pd, import Seaborn as sns, import matplotlib.pyplot as plt, %matplotlib space and line to show all the graphs of the different interface. Now let's set the style for this sheet with sns dot set style. Set style white grid. Now we are uploading a data set which is called Titanic directly from the Seaborn. So let's do this a variable Titanic is equal to sns dot load underscore dataset Titanic. Let's see the Titanic dotted. It will give us the first 5 rows of this dataset. Let's check some more information about this dataset with Titanic dot info. So in total there are 891 ends in this dataset with index ranging from 0 to 890. There are a total of 15 columns as we see. For each, I believe there is a row for each passenger on the ship. The first column gives the information whether the passenger survived or not. I think it's a binary column with 0 and 1 values. 0 for not surviving, 1 for surviving. Then the next column is seat class. It could be class of the passenger seat. Let's check some more information about this. Titanic seat class dot value count. Yes, so there are 3 classes 1, 2 and 3 with 491 passengers for class 3, 216 passengers for class 1 and 184 passengers for class 2. Check total length of this. Got some 891, alright. Survive 0 and 1. Integer value, next 6 could be male and female. And age. Age is a float number. SIBSP is again a float, an integer column. Part is again an integer column. Pair would be float. Again, it's integer type. Oh no, it's float, right? So look at this. Here, this is float. That is, the data type is shown as integer. Bar SCMQ. I'm not sure what that is. Class first, second, and third. I think this is same as E class. Who, man, woman, child. Male. false. Deck, there are 1, 2, 3, 4, 5, 6, 7 decks from A to G. Embark Town. There are 3 towns: Southampton, Seaborn, and Queenstown. So I think Embark in itself is just those 3: S, C, and Q. Yeah, S, C, and Q. Southampton, Seaborn, yeah. Then alive. Are those passengers still alive? No, 549. Yes, 342. So in total, 342 passengers survived that journey alone. True and false again. Alright, so most of these columns are either integer, float, or object. Then there are 2 category columns. One is class, which is first, second, and third, and then second one is deck. We will check the values for deck. Oh, we did, yeah. So there are some man values as well. So data is not available for those rows. Background is an object. Alive, yes, no is an object. Alone, true, false is boolean. Adult mean true, false is boolean. Man, woman, class, man, woman, child for the class. First, second, third is category. Okay, so some of these columns are categories, some are objects, some are booleans, and there are integers and floats. There are 5 different kinds of data type in here: integer, float, object, category, and boolean. Alright, let's start with the exercise 6. First one is recreate the plot below using the Titanic data frame. There are very few hints since most of the plots can be done with just 1 or 2 lines of code, and a hint would basically give away the solution. Keep careful attention to the X and Y levels for hints. Note, in order to not lose the plot image, make sure you don't code in the cell that is directly above the plot. There is an extra cell above that one, which don't overwrite that plot. So let's write here, code here, replicate exercise, plot image below. Be careful not to overwrite cell below, that will remove the excess plot image. Yeah. So it looks like the first one is the joint plot between fair and age. So let's start coding. SNS joint plot. Now there has to be an X. If you look at the code signature, we have to put in an X dataset, Y, and then there's a dataset. So X column, Y column, and then there's a dataset. Find would be scatter, which is already here. We won't worry about color and other aspects right now. Say X would be fair from my dataset. X would be fair and Y would be age. So we have to plot this between this fair column and age column. So we have to check if there is a relationship between the fair the passenger paid versus their age. So X is fair, Y is age, and data is Titanic. There we go. Let's reduce the figure size. When we do it here, 5,4. No, we can't. Fixed size is not a property of the joint plot. So what we can do is can plot plt dot figure and pass in the keyword fixed size is equal to 5 comma 4. This should work. Okay, it's still too big, so I will make it 4 comma 3. Still big. 3 comma 2 would be too small. I don't know how to change this now. Let me see if there is something available here. Height. Maybe I could reduce the height, ratio, space. Size of the figure, it will be squared. Oh, okay. So you can change the height. So if you joint axis height to marginal axis height. Space between joint and marginal axis. Ratio, height. Height should do it. Height is equal to axis shape. Yeah, it's about that same size. Let's make it from 5. So the graphs of both of these diagrams looks exactly the same, except the markers for the scatter plot are much more bigger in mine. I think we could change it with the keywords scatter, keywords, check size is equal to 10. Yeah, 20. If we make it 100, it will become really big. So I'm going to make n that makes it much more smaller. Let's move on to our next figure. Just to plot this figure. This is a pair with what looks like a distribution plot. Now this plot is deprecated, but let's start with that. This plot. Here we have to just pass in the column. Directly from the data set. So let's do Titanic. Okay. So we get a warning that this plot is a deprecated function and will be removed. So we can use either this plot or this plot for this. But in any way, this 0 to 500, it could be a count plot as well. Just with shift plot. First one, which is we change the bin to plot as well. So in total, there are 1, 2, 3, 4, 5, 6 bins from 0 to 100 into 6, 36. Let me put 36 bins. I think now we get our figure. So this is, we can use first plot or we can also use this plot for this. Alternatively, we could have also used the count plot, Let's check what that says. So, count plot x is okay. 10, 10 is equal to 36. So we have a count of all the individual data rows. I'm going to delete this. I'm going to stick with this plot. But you know the estimator for this row column weight fine is histogram false. Oh, alright, there is no estimation. We will move on to the next figure. Next up is a box plot which looks like between the class and age. So let's plot this. It will be SNS plot. Box plot. Here we need an X column, a Y column, and don't we need the data? Yeah, there is a data set as well. So let's start. X is equal to class, Y is equal to age column, and then data is Titan. And let's plot this. Once again, we will try to reduce the size of the figure. It doesn't really matter, but anyway, I'm just checking. There is saturation, there is width. Let's try with width 1.5. Okay, I will go back to default. This is the width of the individual box plot. So the first quartile and third quartile for the first class is between just starting below 30 running till 50. The first and third quartile for second class is about 25 to 35, and for third class it is starting just below 20, what looks like to be 18 or 19, and running till probably 32 here. This is 19 to 32. Alright, let's plot the next one. This looks like a plot, swan plot with same data set. X class, Y is age, and data is Titanic. Okay, I have to put class within inverted commas. Okay, since the points cannot be placed, you might want to replace the size of the markers or use shift plot. Let's see how we can decrease the size of the markers. The size 5. Let's use size is equal to 3. This is too small. Size is equal to 4. And size 5. Then we get the warning that 11% of the points cannot be placed. Let's go back to equal to 4. and we get our graph. Well, it looks slightly different from the graph below. I'm not sure why that would be. Okay, I don't know how to change the y-axis uh, to the groups of 20 rather than groups of 10. That will adjust the figure to look more like how it looks in this uh, plot given here below. But we will just go ahead with this what we have. Now next up is a count plot. We will use count plot for this, SNS dot count plot, press tab and then check what to provide at X column, Y column. I think we only have to provide one for this and then data. So we could rather directly do Titanic with this data column. Now again count plot is asking to pass it as X, so we will do that. Let's adjust the figure size so that it is smaller than what we see now. View data order, orient, color, palette, saturation, dot. Maybe we can use figure size here. UNP dot figure with size of 4,3. Yeah. So for male there are about close to 600 passengers, 500 something, and for females it's just over 300 passengers. Remember, there were a total of 890 passengers. Who, if we check who, there were 537 male passengers. Okay, so it's male, man, woman, and child. But what we plotted here was sex. So there were 577 male passengers, 340 female passengers. And so this figure looks about right. Next up is a heat plot. So that would be a nest dot heat map. We just have to pass our data here. That would be Titanic. Okay, wait. So there are 8 columns in here. So this heat map is a map Titanic dot correlation. So this map has 8 columns. Survive P class age, SIBSP, whatever that is, part, share, adult, underscore male, and alone. And all these same 8 columns are here as well. Survive, P class age, SIBST, March, fair, adult underscore male alone. And the title of the figure is Titanic dot correlation. So maybe I have to build that data set here. Let's call it Titanic correlation underscore for. So for this one we have to use pt dot correlation. How do we get correlation? Well, let be pd. Let's start with the Titanic dot core, and if we check our data set, it will be yeah. So we pass a correlation attribute to Titanic dataset, and it will return the correlation between all the numerical columns. So we get our 8 columns: survive, P class age, SIBST, Parch, fair, adult male, and alone. And now we can plot this. SMS dot heat for the dataset Titanic.core. Titanic.core. They will pass the change the color to tool 1, and again we will change the figure size for this to match what's in the actual figure. We will make it 5,4. This is little bigger than the actual figure, but we will go with this. Alright, here's the last one. This one looks like a Seaborn axis grid, facet grid, looking male and female. So we have to do SMS dot facet grid. We have to pass in the data row and column. The data set is Titanic, and row for this should be 6. Actually, we'll make this column. It's not row, it's column. Now we have to plot. This looks like a distribution curve for age, so it could be SMS dot for Titanic age. Now something doesn't look right. Let's do a count plot. Again, something doesn't look right here. Let's check the data set. We have two categories for the sex column. Those are male and female. So we have created two columns for male and female. And now what we have here is essentially a distribution plot for this age group. So let's check with this plot. What am I doing wrong? Or do we have to pass this as a variable and then use this variable to plot? Yes. Map. Yeah. So I have to map, and here I have to pass SNS dot result x is equal to alternate age. So I will have to check this. So I'm going to stop this video. Okay, I won't stop. I wish I had an option to pause, which I don't. I am just going to check some of my documents to figure out what is wrong here. I am going to stop this video right here and we'll come back to our next video. Thanks for watching.